Aaron Jensen. I'm from Knoxville, Virginia in the United States. My project is Biomaterials for Sustainable Leather Alternatives. This research evaluated zinc oxide and microcrystalline cellulose effects on mechanical properties and UV blocking of sodium alginate and gelatin-based biomaterials. Base biomaterials alone and with 3 different concentrations of each additive were tested for tensile strength, wear resistance, flexural rigidity, and UV blocking. Testing was also conducted on 3 types of conventional materials. Samples were placed in a tensile strength tester which recorded maximum force at failure. Samples were subject to abrasion using a custom wear tester. A custom apparatus was used to measure sample deformation, and a UV sensor measured sample UV blocking ability. 10 trials were conducted on all 14 experimental samples in the 3 conventional materials for each mechanical property test. Due to the inability to accurately reproduce atmospheric UV light, all materials underwent 1 UV blocking test trial. Tensile strength was highest in conventional materials and lowest in base biomaterials. Additives improved tensile strength in sodium alginate and in beef gelatin at higher concentrations. Zinc oxide maintained and improved wear resistance in beef gelatin and sodium alginate respectively, whereas microcrystalline cellulose increased wear. Additives increased flexural rigidity in both biomaterials, with microcrystalline cellulose generally yielding greater stiffness. Zinc oxide blocked UV light in both biomaterials. Microcrystalline cellulose demonstrated complete UV blocking in sodium alginate and partial UV blocking in beef gelatin. 7.5% concentration zinc oxide proved optimal for enhancing tensile strength, having neutral to improved wear effects, providing polyurethane level equivalent stiffness, and blocking UV light. Microcrystalline cellulose increased stiffness and decreased wear resistance. Zinc oxide and microcrystalline cellulose additives can be adjusted for desired mechanical properties depending on specific applications. Bio-based materials support efforts to mitigate negative environmental impacts and health risks. This research introduces potential alternatives to conventional real and synthetic leathers. Future work will focus on combining additives to tailor biomaterials for specific applications.